So hopefully you've taken some time to go over this practice test. Just so that you have this available to you, I'm going to go ahead and go through it quickly. Writing with exponents. So this one would be 3 to the power of 1, 2, 3, 4, 5, 6, 7. This one, the x is to the power of 2 and the y is to the power of 2. Evaluate, remember, means find the value of. So what you're actually doing is multiplying it out. So 3 to the power of 3 is really 3 times itself 3 times. 3 times 3 is 9. Times that 3 gives you 27. 3 to the third, as we just did, is 27. Times another 3, you're going to have to actually multiply 27 times 3. 3 times 7 is 21. 3 times 2 is 6, and 2 is 81. Number 5. Negative 3 to the power of 3. This is telling you negative 3 times itself 3 times. 3 times 3 times 3 is 27, and because it's a negative times a negative times a negative, this gives you a positive times another negative. This is negative 27 times, this one is also negative 27. A negative times a negative is a positive, and when you multiply 27 by 27, 7 times 7 is 49, carry the 4. 7 and 2 is 14, plus 4 is 18. 2 times 7 is 14, carry the 1. 2 and 2 is 4, and 1 is 5. That's going to give you 9, 12, 1 plus 1 is 2, and 5 is 729. So it's positive 729. Evaluate, again, means find the value of. Please remember that when you are evaluating, the very first thing you should do is rewrite the question with parentheses instead of the variable. So it's 3 times g to the third. Then you look at the value of g, which is negative 2. Then you do exponents first. So this is negative 2 to the power of 3, which is negative 2 times itself 3 times. Negative 2 times negative 2 is positive 4, times negative 2 is negative 8. So this is really 3 times negative 8, which gives you negative 24. Number 7, again, please make sure you rewrite the question exactly as it is. So negative 3, open parentheses, g is in parentheses cubed, plus 1. Now you look at g is equal to negative 2. Now you do parentheses first, so you go inside of the parentheses. Within the parentheses, the first thing you do is the exponent. Rewrite what doesn't change. Negative 2 to the third is negative 8 plus 1. Negative 8 plus 1 is negative 7 times negative 3 is equal to positive 21. There's no need to write the positive if it's positive because it's understood that it's positive. Number 8 is similar. Rewrite with parentheses. So g to the 3 minus h. Then fill the g in and the h, which is negative 3. Order of ops says you must do exponents first. Negative 2 to the third is negative 8. Minusing a negative becomes plus a 3. And that gives you negative 5. Number 9, m plus h g to the third. The g is to the third. M is equal to 6, h is equal to negative 3, and g is equal to negative 2. First you do the exponents. That's negative 8. Negative 8 times negative 3, and then adding 6 to it. Negative 8 times negative 3 is 24, plus 6, and your answer is 30. Number 10, write the prime factorization. Remember that prime factors are numbers that only are divisible by 1 in themselves. So when you go to write this out, negative 33, please remember a negative number has the factor of negative 1. So negative 1 times 33, and 33 is really 3 times 11. Negative 1 is prime, 3 is prime, 11 is prime. So this is really negative 1 times 3 times 11, that gives you negative 33, times t. And that's your prime factorization. 11, a to the third is really a times itself 3 times. B to the third is b times itself 3 times. And c is just c. That's your prime factorization. There was no coefficient, no number in front, such as this one that had a number in front, so that one was much more straightforward. All right, let's get into a little bit more intense prime factors. All right, we know that negative 1 is a factor, so we're going to write negative 1 times 80. 80 is not prime. You can use any math fact that multiplies to 80. You will get the same answer. If you use 8 times 10, just remember 8 is not prime, so you have to keep on factoring him. Hopefully at this point you'll remember that 8 is really 2 times 2 times 2. So that'll actually eliminate a lot of work. 8 is 2 times 2, which is 4, times 2, which is 8. 10 is 2 times 5. Remember that negative 1 is still there. So the prime factors of negative 80 are negative 1 times 2 times 2 times 2 times 2 times 5. And to check your work with this, it's really simple. Just go negative 1. This is 4. That 4 times 2 is 8. So this is 8, and this is 10. And 8 times 10 is 80. And then negative 1 is negative 80. But we're not done factoring because we need to factor the variables. S cubed is s times s times s, and then times t. And now you are completely done factoring. That's your prime factors. Find each product expressed using exponents. It's asking you to express using exponents. So do not multiply it out. Okay? Don't multiply out. They just want expressions. So in this case, this is like saying there are 3 3's being multiplied, and 3 to the 6th, there are 6 3's being multiplied. In reality, you have 3 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9. That is what they're looking for, the expression using exponents. Also remember the shortcut. When multiplying variables with the same base, you add their exponents. So you could have just said, keep the base, and then 3 plus 6 is 9. But when in doubt, write it out. Make sure you just write it all out if you don't remember the rule. When multiplying with coefficients, which are the numbers in front, remember, if I was to draw this out the long way, it would be negative 3 times d times d times d times 11 times d times d times d times d. Using the commutative property, you would be able to move things around, and then you would be able to just multiply negative 3 times 11, which is negative 33. And if you have 3 d's here and 4 here, you have 7 total. That's your final answer. Without writing it all out, you would just simply do negative 3 times 11 is negative 33, and then you would say d to the 3 times d to the 4. When multiplying variables, add their exponents. So it's d to the, and then you add 3 plus 4, and that's where you get the 7 for the exponent. All right, number 15. Now, instead of using the dot to symbolize multiplication, we're putting it in parentheses, but it's the same exact process. Negative 20 times 5 is negative 100. X to the third times x to the 2 is x to the 3 plus 2, which is 5. When multiplying variables, add their exponents. If you get stuck with those rules, write it out. This is telling you x times itself 3 times. The other one is x times itself twice. So in reality, what you really have is x to the 1, 2, 3, 4. There are 5 of them. So that's where we get the x to the 5. Great. Now we're finding quotients, which is division. Remember, it's a division, it's a fraction, whatever helps you understand that this is really negative 20 divided by negative 5. Negative 20 divided by negative 5 is positive 4. A negative divided by a negative is a positive, and 20 divided by 5 is 4. A to the third, if you wanted to draw it out, is a times itself 3 times, and then a in the denominator. Anything over itself divides away. So really you're left with 4 on top, 4, and a to the 2. That's your answer. If you wanted to draw it out, or if you wanted to do it the other way, you could just say negative 20 divided by negative 5 is positive 4, and a to the 3 over a to the 1 is a to the 3 minus 1, which is 2. Again, if the shortcut rule does not stick, write it out the long way. 26 divided by 13 is 2. X to the 5 over x to the 3, you can draw it out, and then remember that anything over itself divides away. It becomes 1, so it divides away, and you're left with 2 x to the 2. The denominator is just 1, but you don't have to rewrite that. You just write it as a whole number looking. All right, now we're talking about negative exponents. Remember that a negative exponent is really telling you that it's a fraction and that it's in the wrong place of the fraction bar. So anything to the power of a negative exponent is really going to be rewritten in the denominator as a positive. So it switches the sign. So this one, imagine, and if it helps you to imagine that there is a fraction bar, then what you can do is you can say, all right, if I draw the fraction bar, this has to come down to the bottom. Now it becomes positive, but in the numerator, there's a 1. It wants you to write it using a positive exponent. It doesn't want you to multiply it out. So if you just left it as 1 over 2 to the third, it's totally correct. B to the negative 3, again, the b to the negative 3 needs to be brought down to the bottom. And now, in order to make it a fraction, we put 1 in the numerator. (20 through 22 is asking you to evaluate with negative exponents. So the first thing you need to do is rewrite it with a positive exponent. So this is really 1 over p to the third. Then rewrite it so that instead of the p, you have a parentheses, so that then you could take that value and place it in, and then you evaluate. Find the value. Here you have to multiply it out. 3 times 3 times 3 is 27, because 9 times 3 is 27. Number 21, 4 to the power of m. Well, m is negative 2. That's really 1 over 4 to the positive 2, which gives you 1 over 16. Okay. This one's just a little bit confusing. Rewrite it with parentheses if it helps you. Something to the power of negative 2. N times p. Well, n is 2 and p is 3. This gives you 6. So that is really parentheses to the negative 2, but the inside is now 6. Which then I can go ahead and rewrite that as 1 over 6 to the 2, which is really equal to 1 over 36. Now, we are raising powers to powers. Power to power, multiply the exponent. This is really 4 to the power of 2, x to the power of 2 times 2, which is 4. That simplifies to 16x to the 4. If you needed to write it out, you would do it the following way. You would say, we have 4x to the 2 twice times 4x to the 2. That's what this exponent is. Then from here, you could say 4 times 4 is 16. And then if you needed to draw it out even more, you could say this is really x times x, as this is. And so in reality, it's 16x to the 4. Either way, you get the same answer. So whatever works for you is totally fine. All right. This is telling you there are 3 sets of this. If you use the shortcut, you would say negative 2 to the power of 3, which is negative 8, and z to the power of negative 9 multiplied by 3 is negative 27. Power to power, multiply the exponents. So when you have that, you realize that the exponent that's negative is the z. Negative 8 is just a negative number. It's not the negative exponent. Negative 27 is the negative exponent. So negative 8 remains where he is, and z to the negative 27 comes down to the bottom and becomes positive. If you needed to write it out, you could say to yourself, I have negative 2z to the negative 9 3 times. Each one of these has to be rewritten so that the z's are in the denominator and become positive. It goes down. Then, when you go ahead and multiply across, negative 2 times negative 2 times negative 2 is negative 8. And z to the 9 3 times means you have 9 z's, and that is the same everywhere else. So I'm not going to draw out 9 z's here and here. If you have 9 here, 9 here, 9 here, that's a total of 27. So either way, you get the same answer. Whichever way works for you, you're welcome to do. All right, if I use the rule, power to power, I'm going to distribute that exponent, so that's really 4 to the power of 2, b to the power of negative 4 multiplied by 2, which is negative 8. This is really 16, and the b to the negative 8 gets flopped down to the bottom and becomes positive. That's your answer. I hope you do review. This is exactly like the test, you guys. I just basically created a new test, new questions, so that you would know exactly what's on the test.